Welcome, class. Today, our session title is Week 1, Session 3, Scientific Notation and Significant Figures. We will move slowly and make the chemistry understandable. Your goal is to write measurements in scientific notation and report answers with appropriate precision. Listen for these key terms: scientific notation, significant figure, precision, rounding, measurement. First, keep the three chemistry levels together. Chemistry uses very large and very small quantities: 602 million, 200 billion, 200 billion, 200 billion particles, atom scale distances, and tiny masses. Scientific notation keeps these quantities readable. Significant figures communicate measurement precision. When you feel stuck, ask, what did I observe? What are the particles doing? And what symbol or calculation represents it? The core model is this. For multiplication and division, the answer should have the same number of significant figures as the measured value with the fewest significant figures. For addition and subtraction, the answer should be rounded to the least precise decimal place. Do not rush to an answer. Build the model first, then let the model guide the calculation or explanation. Now let's work an example. Multiplying measured quantities. A student calculates density using mass, 12.5 grams, and volume, 4.00 milliliters. Density equals mass per volume equals 12.5 divided by 4.00 equals 3.125 grams per milliliter. Both measurements have three significant figures, so the answer should be reported as 3.13 grams per milliliter. Notice how the answer comes from evidence and reasoning, not from guessing. Here is a second example. For addition, 15.20 G plus 3.1 G equals 18.30 G by calculator. But the second measurement is only precise to the tenths place. The correct reported result is 18.3 G. The rule protects you from pretending your data are more precise than your tools. Now answer this self-check. How many significant figures are in 0.0405? A strong answer should include 3. Hint: leading zeros do not count. Zeros between non-zero digits do count. Before you leave, practice actively. Task 1. Write 0.000672 in scientific notation. Task 2. Round 24.786 G to three significant figures. Task 3. Calculate 8.40 per 2.1 and report the answer with correct significant figures. At the end of your study, write one sentence beginning, "The chemistry idea I must remember is." For more practice and exam preparation, visit www.bridgetoexam.com.